go.
Hi guys, my name is Karen Harper. This is my first MECOP internship. So I was with the ASIC design group. My manager's name was Matt Junker, and my mentor's name was Kevin Cosgrove. So a little bit about me. I'm a junior at Oregon State University, starting my senior year. I'm in electrical and computer engineering with minors in chemistry and physics. Wow, it says math. I should not say that. Can we start over?
Sure.
Shoot. See, the thing is that I've been doing that actually, because in my head my minors are chemistry and physics, but on the books it says math and chemistry. Dang it. See, if I change it to physics, I'll say math. I know I will.
Well, and also, how to say, if you get it wrong, just carry on, right? I mean.
Right. Okay. Dang it. I hadn't actually said that out loud before. That's okay.
Mm-hmm.
I'm giving my presentation. You want to see it? You can stand over there. It's really great. I'm talking about what I did for 6 months. And I just forgot which minors I have. So everything's going really well.
Oh, you know what? Nobody will know, right? I mean, just say it and carry on.
Except for the... Okay.
Oh, if it doesn't match the slide.
If it doesn't match the slide, yes.
Yeah,
that's the issue.
Okay.
I need it to match the slide. Anyway.
Okay.
Also, if you can come up with a different thing to call this than literally the words MECOP internship, I would love that, because that's really gross. Anyway.
It's self-explanatory, though, so...
You ready?
Right, ready when you are.
Not have my hands in my pockets. Hi guys, my name's Karen Harper. This is my first MECOP internship. So I was with the ASIC design group. My manager's name was Matt Junker, and my mentor's name was Kevin Cosgrove. So a little bit about me. I'm a junior at Oregon State University. I'm majoring in electrical and computer engineering with minors in chemistry and math. I'm graduating in spring 2019, hopefully. My hobbies include board games, reading random Wikipedia articles, listening to music, and attempting to bake things. This is a really fun picture. This is a caramel stuffed chocolate cookie that I tried to make once. I found it on Pinterest and they looked great, but the caramel didn't melt inside. So it was like a cookie, but with like an entire caramel in the center. They were really good, but they didn't look great. So that's why I'm an electrical engineer.
Okay.
So this is the project I did. I made a preamplifier. I made a test board for preamplifier ASIC. So ASIC stands for Application Specific Integrated Circuit. And the problem that I was presented with is that there was this major family of preamplifier ASIC chips. There's the 61A, 61B, and 75 that are all going in major products, but there was no way to easily perform tests on them. So they were in boards that were going in the oscilloscopes, but those had a lot of other components in them, and so you couldn't easily run tests on that specific ASIC to see whether or not it was functioning. So, yeah, there were multiple versions of the preamplifier that you needed to do isolated tests on. So my goal was to develop a PCB, which is a printed circuit board, that had basically only the ASIC and the necessary circuitry to run it so that you could easily perform isolated tests and de-embed the ASIC from the system in order to see what the literal package is actually doing. So design and implement a way to mount each ASIC with little signal loss, and then include all the necessary calibration structures, power supplies, signals, everything that it needs to run, but nothing more, if that makes any sense.
Very nice.
So the first step in making any printed circuit board is to make a schematic. So the good thing about this project is that I was able to take a lot of my schematic from a board that already existed, the analog front-end board from the new oscilloscope GNOME.
Mm-hmm.
So I worked a lot with the hardware design engineers on Elemental, and then later when that project ended on GNOME. That board has 4 channels, so I took 4 of those 6 channels off, as well as most of the output connectors, onboard power supplies, attenuators, the tone generator, anything that didn't have to do specifically with powering the 61 ASIC itself. Then I added on voltage references, input and output connectors from the chip itself, another over temperature response, and power in order to run that specific package.
Okay.
So after the schematic was done, I moved to the layout. I was kind of in a unique position for this internship because there's the PCB schematic group and the PCB layout group, and they're completely different, but I acted as both of them, which was kind of interesting. I worked very closely with the layout group, mechanical design, in order to very specifically place where the ICs and different mechanical connectors and mounting holes and stuff like that would go. BBO and CSO to make sure parts were available and placed properly. I also initiated contact with Wild River LLC. They make high-speed connectors, so hopefully this Tech 75 will be able to run at 26 gigahertz, which is really, really fast. So in order to have a system run at 26 gigahertz, you need your testing to be able to run faster than that. So we found these low-cost, locally made 40 gigahertz connectors. That was really cool. It also added VNA calibration lines in order to effectively de-embed the ASIC itself from the transmission lines that were running it in the inputs and outputs from that. So here's kind of the original idea. There's just like the ASIC itself, and then the transmission lines going from the inputs and outputs, and then a power bus and the serial supplies. There's my final design, so you can kind of see we have two ASICs, one right here and one right here. These are the transmission lines that I made. These are the calibration lines right here. These tiny little things are the Wild River connectors. If you can see that, that's Benny the Beaver. And this entire 6 months right here is like that big, which is kind of crazy to think about for me. I don't know if it means anything to you guys. I hadn't taken transmission lines before doing this internship, so the entire concept of the fact that signals work differently at high frequencies is something that I learned completely here. As I said before, the Tech 61A and the 61B run at 10 gigahertz. The 75 is an experiment to see if they can run that up to 20 or 26 gigahertz. So all the connections into and out of those ASICs, those are called launches, just any connection in between a connector to a signal or a signal to an ASIC. Those had to be really, really specifically designed for transmission line properties at high frequencies. A ton of work went into designing that launch that was very, very specific, like thousandths of inches either way. It was a really cool thing to be a part of. I worked a lot with a signal integrity engineer in order to simulate and optimize those launches. You can kind of see here, so this is the 61A. It's a lot easier to run into that because all of the signals come directly out of the package. The 61B, I don't know if you can see that, but the signals go under the package for a little bit, and so anything that's under the package here has chip over it still, so it's just a completely different electrical, all the characteristics are different, so we had to do that completely on our own. Here's a picture of my really pretty transmission lines. I'm so proud of them. They're super pretty. I redrew those things so many times. They were great though. So here's my accomplishments. I created a test board which will be able to test effectively at least 3 generations of preamplifier ASICs, the 61A, B, and the 75. Will aid in product testing, hopefully, ultimately help ensure quality of product, speeding up time to market, all that good stuff. It will be taped out soon before I leave, and then it will be back and populated and ready to test ASICs in 3 to 4 weeks. This board is the first board to have a 61B on it. So I drew the first launches out of the 61B, which is really cool. And since that's now done, it's been checked off by the signal integrity team and all that stuff is good, that launch itself can now just be copied and pasted basically into any other board that has a 61B in it. So GNOME or any of the other stuff. That's just, that's available now. I also established initial contact between our ASIC design team and Wild River Technology, so if we want any more of those cheap 40 gigahertz connectors, that'll be a lot easier now. Stuff that I learned. So I had made PCBs before, but nothing really on this order of magnitude. So I used a much more sophisticated PCB design tool, Allegro Design Entry HDL, and PCB Designer. understanding of what goes into a test system, from like the benchtop stuff, the power supplies and the computer and the software, to the test board, everything that goes on there, and then to the ASIC, kind of those 3 levels, is something that I entirely learned here. Basics of transmission line theory, as I said, I picked that up all here. So basic understanding of termination, propagation, reflection, anything that has to do with the shape of a transmission line versus the signal that goes through. A ton of what went into the 61B, the launches in there, is which ground to use, which was something that I never really thought would be that much of an issue. So that was a really cool thing. I conducted between 2 and 4 technical design reviews of my board. I kind of stood up in front of a board of like senior engineers and presented the board, and they gave me feedback, and it was super scary, but it was really, really great, and I'm much more confident in giving technical presentations now, which is good. I worked with a lot of different people during this internship. There was the IC team and the PCB schematic team and the layout team and the signal integrity guys and all this stuff. So I had to figure out how to easily and efficiently determine each person's expertise so that I could go to them later for help. I very quickly realized that if you ask the IC people about the PCB layout tool, they won't have any idea what you're talking about because that's not the tool they use. I was actually really surprised. That was one of the things that I took away from this, is that everybody was just so nice, and they were so happy to help me. I was just this lowly little intern. They didn't know who I was. They'd been working together for 16 years, but they were just so good to me, and they really made me part of the team. They took me out for drinks on my 21st birthday, and they put clown statues in my cubicle, multiple clown statues. But they were really, really great, and it was a great experience. So that's about it. Have any questions?
Not today. Thank you.